This is propositional equivalences. So in the previous section we talked about propositions. Now the propositions can be put together with connectives, and then they form compound statements, right? So compound statements can take true or false values depending on the values of the propositions they consist of, right? When a compound statement always is true, we call that a tautology. So regardless of the values of the propositions in that compound statement, it always evaluates to true. So if you were to build a truth table and all the rows in your truth table at the very end are true, then you have a tautology. On the contrary, if all of the values for this compound statement are false, regardless of the values of its propositions, P, Q, R, S, then you have a contradiction. If you have a combination of true and false values in your truth table, then you have a contingency. So there are cases that can be evaluated very quickly without actually building a truth table. So we have these equivalences that are called the logical equivalences, and you could prove that these are true by constructing the truth tables and then looking at the values of both sides and verify that the truth values are the same in the truth table. So but by the way, logical equivalency is denoted using this little symbol here, so don't confuse that with the double implication. The double implication has only one arrow with the two arrowheads, but the logical equivalence has two lines and two arrowheads. Okay, don't confuse those two symbols. That's also a very common mistake students make. So you can verify the validity of these equivalences by building the truth tables. If you want to do that on your own, you're more than welcome to see. It will help you reinforce your knowledge on these logical equivalences. Just as you have in basic arithmetic, you have the associativity. So if you have only one connective, in this case, for case 1, only ORs, all true is or, then you can rearrange the brackets any way you like, and that is not going to alter the truth value of your compound statement. The same if you have only ANDs, you can rearrange the brackets the way you like. The distributivity is also very similar to what you have in arithmetic. If you have multiplications and additions, let's say that the OR is the addition and the AND is the multiplication, and if you wanted to rearrange these brackets, so what you do is you, let's say, multiply P times Q, and that becomes P or Q, and then you have an AND in between, and then P or R. Okay, and the same thing is going to happen for the inverted case. A good way of associating this is by, as I said, looking at arithmetic. It's very similar. Then we have the double negation. The double negation will turn the truth value of that variable to its original value. And in general, if you negate something an even number of times, the truth value of the compound statement you are negating, or the preposition you are negating, is not going to change. It's always going to be back to the original value. But if you have an odd number of negations, then the truth value is going to be inverted. And it makes sense. I can tell you it is not the case that Toronto is not the capital of Canada. So it's the same as saying Toronto is the capital of Canada. So a double negation. Then we have the Morgan laws, and also this is kind of also to remember these laws, you can associate it with regular arithmetic. We have the absorption laws, so you have different symbols here, P and Q, and then P with an OR. That's the same as P, and it makes sense, right? This is an OR, so it doesn't matter what this is gonna be. Always, if P is true, then true, and this may be false because Q may be false, but P is true. So P true or something, whatever, becomes the same as P. And you can do a similar analysis for part 2. Or again, you can write the truth tables and verify that these are all correct. Finally, we have the negation laws. So P or the negation of P, and P and the negation of P. Okay. So we'll do those exercises during the synchronous session.